Hello everyone, welcome to our lesson. We're going to look at the Chord theorem in this lesson and we're going to look at the proof. Remember, the proof for Chord theorem is examinable. We must know how to prove this theorem. And I'm going to show you three methods to prove this theorem, okay? What does the theorem say? Let's look at our first part. What does the theorem say? Right, now before we look at what the theorem says, I want us to name these components of a circle. Right, you can pause the lesson here and try to name the line DC, the line AB, and then what is section E, what is section F. It is very, very important that we understand these components before we look at the Chord theorem. Let's try that. Right, welcome back. Did you manage to name line DC? What is line DC? Line DC is the tangent. Line DC is the tangent. What about line AB? From circumference to circumference, what is it? It is the chord, right? It is the chord. Today we're going to be looking at an angle formed by the tangent and the chord. Okay, that's chord, tangent chord, right? And then what about section E? This section here, this is what we call it the major segment. It is the bigger segment. And then F is the minor segment, the other segment. So when I'm saying the alternate segment means the other segment. You see that? Okay, we're going to be using those terms as we are going to be doing this lesson. Right, so this is the minor segment, okay? Right. Now, what does this theorem say? An angle between the tangent to a circle and the chord, an angle between the tangent to a circle and the chord drawn from the point of contact. Okay, this is what? This is the tangent and the chord, and is drawn from the point of contact there, B. Okay, this angle here, B2. That's the angle we're talking about. So the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Do you see the chord BD? The chord BD, what does it do? This chord BD, it divides the circle into two segments, the major segment and the minor segment. You see that? So now there's an angle which is formed on the major segment here, and then that's the angle we're talking about. So that's the angle in the alternate segment. You see that? Okay, so the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. That's the chord theorem. Okay, that's the chord theorem. So the reason you write, just say chord theorem. Okay, again, we can talk about this angle. I'm not going to say much, but B1 also, we can say B1 is equals to angle D. Do you see that? Do you see that angle D is subtended by chord EP? Okay, right. And then angle B1 is formed by the chord AC and the chord is not the chord. Angle B1 is formed by the tangent AC and the chord EP. Do you see that? And then EP subtends angle D. That's another good example there of what? Of a chord theorem situation. Okay, so angle B1 is also equal to angle D, and angle B2 is equal to angle E. Now, we are going to be proving this theorem. Okay, we're going to be proving this theorem. Let's go to the proofs. If a line drawn through the end point of a chord, and then what does that line do? Making with the chord an angle equal to an angle in the alternate segment. Okay, let me just read again. If a line drawn through the end point of a chord, making with the chord an angle equal to an angle in the alternate segment. You see that? Right. This is a line drawn through the end point of a chord. And then it's making what? An angle with the chord. And then this angle is equal to an angle in the alternate segment. Do you see that? So we have angle B2 and E. And then if these two angles, B2 and E, are equal, then AC is the tangent. You see that? Then AC is the what? Is the tangent. That's the converse theorem. And then the reasons you write you can say converse chord theorem or angle between line and chord. Okay, Right, let's look at our first proof. I said I'm going to show you 3 of them. But if you have learned about this, can you try before I show you how you do it, okay? Because you have covered this, especially if you're in grade 12, you have done this in grade 11, so it means that you have an idea, so try. But grade 11 also, maybe you've done it or maybe you have not done it, it's fine, okay? Right, now let's go to the proof. Right, given a circle with center O and tangent AC, do you see center O and tangent AC there? Prove that angle CBD is equal to angle BED. Identify the angles there. This is angle CBD, which is B2, and then angle BED, which is E, basically E, this angle here. We want to prove that these two angles are equal. And then now, what do? We usually construct. And then when you're constructing, we're trying to use the previous theorems that we have learned about to prove this theorem that we're talking about now. So I'm going to, what do we construct here? We construct the diameter, and then we join that to and then let's name it F. You can name it anything, and then there you join those two. You see, you have formed a diameter there. We have formed an angle in the semicircle. Do you see that? Okay. You have also formed angles in the same segment. Do you see that? Okay. Right now, so we can say that angle BEF. What can you say about angle BEF? Let me write it down here. Angle BEF. What can you say about angle BEF, which is angle BEF? What can you say about it? What is the size of this angle? It is equals to, BEF is equals to 90 degrees. BEF is equal to 90 degrees. Okay, because it's what? Because it's an angle in the semicircle. Right, angle in the semicircle. Let me write that. It's an angle in the semicircle. Okay, angle in the semicircle. Right, now we go to which one now? Can you say, look at angle CBO? Angle CBO. Can you try to find the size of angle CBO? What can you say about angle CBO? Angle CBO is equal to what? Is equal to 90 degrees. Why is it equal to 90 degrees? Because it's tangent perpendicular to diameter. You see diameter BF there. That is diameter BF, the diameter that we constructed. So BCBO is 90 degrees. So do you see that angle BEF and angle CBO are equal? Yes. Now, what do we do next? What do you think? We can see that angle E2, where is angle E2, and angle B3 are equal. Why is angle E2 equals to angle B3? Let me write it down here. We can say angle E2 is equals to angle B3. Why is angle E2 equals to angle B3? They are angles in the same segment. Angles in the same segment. Angles in the same segment. Okay, if you check, they are subtended by the same chord, or they're just subtended by the same arc. Right, same chord FD there. Okay, this is the chord that subtends. This is the chord that subtends angle E2 and angle B3. Okay, right, and then what else do we have here? If we check, right, it means what? It means angle E1 plus angle E2. That is the whole angle BAF, isn't it? So angle E1 plus angle E2 is equals to 90 degrees, isn't it? We say that angle BEF is 90 degrees. And angle B2, plus angle B3 also is equal to 90 degrees, because we saw that angle CBO is 90 degrees. Okay, so angle B2 plus angle B3 angle B2 plus angle B3. Okay, angle B2 plus angle B3, not B2 again. Right, and then remember we say these two are what? Are equal. These two are equal, isn't it? No, here. Angle E2 and angle B3 are equal, isn't it? Because they are angles in the same segment. Meaning that if angle E1 plus angle E2 is giving us 90 degrees, and angle B2 and angle B3 is giving us 90 degrees, therefore, angle E1 is equals to angle B2. You see that? Okay? These two things are equal. This angle and this angle are equal. So if we're adding this angle E2 and E1 and getting 90, and adding B3 and B2 to get 90, therefore E1 is equals to B2. You see that? So now we can say this angle here is equals to this angle here. E1 is equals to B2. Now we have proved that, therefore, angle CBD, okay, is equals to angle BED. Because if you check angle angle B2, that is CBD, angle CBD, and angle E1, that is angle BED. We have proved that. We have done the first method of proving the tan chord theorem. We're going to do another one. Okay, now let's go to the next one. Right, let's look at this method now. It says, given a circle with center O and tangent DE, prove that angle ACB is equal to angle EAB. Angle ACB, this is the angle ACB, and then angle EAB, this is the angle here. Okay, you see that? Now we're going to prove that these two angles are equal. Okay, we're going to prove that these two angles are equal. So what we do, we construct from our point of contact, we draw the diameter, and then we join like this. Okay, right, we join F to C there, and then we create an angle in a semicircle. Right, so now what can we say? We have angle, let's start with angle A1. What can you say about angle A1? This is angle A1. It is 90 degrees. Angle A1 is 90 degrees. Why is angle A1 90 degrees? Let me write A1 here. I almost wrote 90 degrees before. Right, is 90 degrees. Why is angle A1 90 degrees? Because it's tangent perpendicular to diameter. Remember, we talked about this in one of our previous lessons. Right, so A1 is 90 degrees because it's tangent perpendicular to diameter. What can you say about C1? C1 is also equal to 90 degrees. Why? Why is C1 equal to 90 degrees? Because it's an angle in the semicircle. Angle in the semicircle. Right, that is what angle C1. And then now we have our chord BF there. Okay, it subtends angle A2 and angle C2. So we can say that angle A2 is equal to angle C2. Why? Because these are angles in the same segment. These are angles in the same segment. Okay, do you see that? Now, if we check here, angle ACB, what can you say about angle ACB? Angle ACB, angle ACB, the whole angle there, that will be equals to angle angle C1, which is 90 degrees, is going to be 90 degrees plus angle C2. You see that? Is equal to 90 degrees plus C1 plus C2, isn't it? C1 plus C2, but C1 is 90 degrees. And then angle angle EAB. Angle EAB, again is 90 degrees plus what? Plus A2. You see that? Because angle EAB will be A1 plus A2. Do you see that? Okay. So now we say that C2 and A2 are what? C2 and A2 are what? Are equal. So it means here we're saying 90 plus C2, 90 plus A2, and then we're adding things that are the same here. C2 and A2 are equal. So meaning that this angle ACB is equal to angle, what? Is equal to angle EAB. Therefore, angle ACB is equal to angle EAB. We have proved that these two angles are equal. Done. You see that? Okay. Right. Let's look. Well, we're going to look at the last one, the last method. Then we'll be done. Let's go to the next one. Before we go to the next one, I didn't show you nicely the angles that we proved. Let me just show you. This is the angle we're talking about, ACB, and angle EAB. Okay, let's go to the last one, the last method for proving the tan chord theorem. Right, now, given a circle with center O and the tangent AC, prove that CBD is equals to BED. Can you try to identify the angles? Where is angle CBD? This angle here. And then BED, which is this angle here. I want to prove that these two angles are equal. Okay, so what do we do? What construction can we make here? Okay, we can also construct our OB and OD. Do you see that? Which theorem do you think we can use here? Angle at the center is equal to 2 times angle at the circumference. Okay, so what you do here, let E, the angle there by the circumference, let's say let angle E be equals to X. Let angle E be equals to X, isn't it? Okay, right. Now, what can you say about angle OBOD? So therefore, angle BOD is going to be equals to 2x, isn't it? Angle BOD is equal to 2x. Why? Because angle at center equals 2 times angle at circumference. You see that? So that is 2x. And then if you check here, triangle BOD is an isosceles triangle because OB is equals to OD. These are radii, isn't it? Radii. Okay, so we can say that B3 and angle D, they are equal. Okay, B3 there and angle D are equal. So we can say that angle B3 is equal to angle ODB. Because it's an isosceles triangle, we can say 180 minus 2x divided by 2. Why here we say it's angle sum in triangle, and also we're using that angles opposite equal sides, right? Because OD is equals to OB. You see that? Right. So now we can find that this angle B3 is equals to angle ODB, which is equals to 90 degrees minus x. You see that? So these two angles, this is 90 minus x, and then this one is 90 minus x. Now, what can you say about angle CBO? Angle CBO. What can you say about this angle? It is equals to 90 degrees. Why? Because tangent perpendicular to radius. Tangent perpendicular to radius. So it means this whole angle here is what? Is 90 degrees. Now we can find angle B2 here. If you say 90 minus x, we are subtracting this from 90, then we'll get B2. Do you see that? So we say, therefore, angle B2 is going to be 90 minus 90 degrees, 90 degrees minus 90 degrees minus x, okay, like this. Then we remove the brackets by distributing the negative. So it's negative 90x here plus x. You see that? Then it's equals to x. So we prove that B2 is equals to x. Do you see that? So now we have proved that the angle, therefore angle CBD is equals to angle BED because both of them are equal to x. You see that? Right, done. Right, let's conclude our lesson. We talked about the converse in the when we started, isn't it? We talked about the converse, say that if a line thrown through the end point of a chord making with the chord an angle equal to an angle in the alternate segment, then the line is a tangent to the circle. You see that? Now, if if it can be proven that this angle here, which angle, if it can be proven that angle B2 is equals to angle E, or if it can be proven that angle B1 here is equals to angle D here, then we can say this line AC is what? Is the tangent. That's a converse theorem. Okay? Right, we have finished the lesson. I really hope you managed to learn something from this lesson, learners. Okay? Right. Please don't forget to subscribe to our channel. Please subscribe our channel. You can even visit our website. You're going to get more information there. And then you can also go to our YouTube channel and go to the playlist where the lessons are well arranged and you can benefit from them. Let's meet in our next lesson. Goodbye.